here is the last section of these particular notes. I want to point out that this is 9.5 part 2, or 4.5, but this is still part 2. The homework will be set as 2 separate homeworks, so make sure you turn them in as such. On this one, part 1, you learned how to find the asymptotes so that you can graph these things, and now we're going to use those to graph. So a rational function is an equation of the form p of x over q of x, so fraction over fraction. Vertical asymptotes are going to be x equals, remember this is where the denominator equals 0. Don't forget about your point of discontinuity is a reducible value, but it becomes the whole in your graph. And I'm pretty sure we have one example of that. Horizontal asymptote, you have 3 different types. Powers are the same. So you're going to have a y equals a over b, y equals 0, or none. And this is always going to be in the form of y equals, say, well, let's go ahead and use it, mx plus b. This would be a vertical asymptote, horizontal asymptote. If you had an oblique, it would go this way or this way. And what's in red is your graph. Okay, and they're showing you the equivalent of the oblique asymptote. It goes this way. You have a vertical and an oblique, and what your graph does. Watch these ones when you throw them in a computer, because many a times only this part of the graph shows. Okay, so make a hand-drawn graph for each. Be sure to label all your asymptotes and so forth. So, horizontal asymptote, you're going to get 0x over x. Anyways, there's no x on top, so 0x over x, which is going to give you y equals 0. So that's going to be this guy. So this is your horizontal asymptote. Point of inflection, point of discontinuity is going to be none, because you cannot reduce the 2 and the 4. There's no term down here. Well, actually, let me repeat. Only term in the denominator is x plus 4. There's no x plus 4 in the top, so I can't reduce it. Vertical asymptote, x plus 4 equals 0, so x equals negative 4. So at negative 4, 1, 2, 3, 4, this is going to be your vertical asymptote, but we'll draw it in. Vertical asymptote, horizontal asymptote, and your graph will not cross these guys. And now the last part, where it tells you list the domain and the x and y intercepts, that's going to get you into graphing it with a little bit of ease. So on these ones here, we'll try to make it some nice numbers, but if I put 0 in for x, I'll have, so if x equals 0, then y is going to be 2 over 4, or 1/2. So at 0, I'm at 1/2. So if I go with 1 to negative 3, I'll get 2 over negative 3 plus 4, which is going to be 2 over 1. So I'm here. So we can see on this side of the graph what the graph is looking like. Now here's something I want to show. These things have symmetry about where the vertical and horizontal asymptotes cross. So to get to the other point, go backwards, down 2, over 1, over 1, down 2. Okay, and now to show that this really is, if I put negative 5 in, I'll have 2 over negative 5 plus 4, which is 2 over negative 1. And this point down a half, 1, 2, 3, 4. So 1, 2, 3, 4, down a half. And that's all you have to do. Very symmetric about this spot right here. Now, if you don't have a horizontal asymptote, then it's going to be symmetric to your x-axis and the vertical asymptote. Okay, so this is going to just come down as such. And this one's going to come down as such. Now, yours will look a lot nicer. All you need is those 2 points. You need to get some 2 good points in there and graph it. Now, if I was to list the domain would be all real numbers except for negative 4. And the range would be all real numbers except for y cannot be 0. Okay, let's try another one. Okay, so horizontal asymptote. I have x over x squared, which is going to give me 1 over x, which implies y equals 0. Point of discontinuity, well, we have to factor for that. X plus 2 over we have negative 6, negative 1. So factors of 6 that add up to 1. They're both negative, so one of these is negative, the larger of the two. So I have x minus 3 and x plus 2. And there it is. My point of discontinuity is at x equals negative 2. We'll come back to that guy. Vertical asymptote. Take what's left of your denominator and set it equal to 0. X minus 3 equals 0, so x is equal to 3. So let's go ahead and draw those in. Horizontal asymptote, y equals 0. Vertical asymptote is x equals 3. So horizontal asymptote, vertical asymptote. And now we have this point of discontinuity on our graph at x equals negative 2. So something I want to show is that when I reduce this, I'm left with 1 over x minus 3. Now, I know at negative 2 I have a point of discontinuity, but I don't know the y value. I can now plug the y value into this. 1 over negative 2 minus 3, negative 1/5. Now, I'll tell 1, the negative, doesn't matter where it goes, the fraction's negative. 2, I can't put negative 2 into this guy. That's 0. Once I reduce them out, remove them, I'm left with this. This, I can plug negative 2 in. So, at negative 2, my value is negative 1/5. So I'm just barely off the y-axis. Sorry, x-axis. So let's grab some points. I'm only going to put points into this guy. Why? To make my life easier. So if I'm at 3, if I put in 2, 1 over 2 minus 3 is going to give me 1 over negative 1. So at 2, I'm at negative 1. Now remember the thing, up 1, over 1, over 1, up 1. And you can do the same thing for this guy if you wanted to. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and up. Ooh, and I just caught what I did here, or I didn't do. So I'm going to take a little eraser. And remember, this is the point of discontinuity, is a hole. So at -2, right about here, I have a hole. And you will draw a hole. And now I can sketch the graph. Do this bit. It's going to come to this guy, and then it's going to jump over him and keep going. And this side of the graph will do the same. Okay, I sort of missed the actual line, but I have the advantage I can do this. Unfortunately, you do not. But it's a little bit easier to draw on paper than on these. Okay. And then this one here, horizontal asymptote, x squared over x gives me x. Remember, you don't get a fraction or 0, it is none. Point of discontinuity. This is the difference of squares. It's x plus 5, x minus 5 over x minus 5. So these will cancel out. They'll reduce out. So this is going to be x minus 5. So x equals -5. Sorry, positive 5. And then vertical asymptote. There is none, because what was in the denominator, I already reduced out. So I'm only left with x plus 5. So if I was to draw the graph, actually, we're left with nothing more than an oblique asymptote of y equals x plus 5, except for when x equals 5. So 1, 2, 3, 4, 5, and slope of 1. So we'll go here and here. And yes, I'm going to cheat and use, well, I don't want to use that one. And I'm going to just use a line. There we go. And if we were to go all the way to x equals 5, I'd have to put a hole in the graph. Honestly, if you were graphing this on paper for like a homework problem, I would expect to see that hole in the graph. But since that will go quite a ways off my graph, let's see, can I make it 1, 2, 3, 4, 5? Let's see. 1, 2, 3, 4, 5, and this is 6, 7, 8, 9. I would say somewhere around here would be my open graph. And then I would have to start it again. Okay. This one is a little bit different than most of them, because you don't usually get just a line left over. Now, this one, I believe, no, I guess not. I thought I left this one to do in class. But I don't have any of them written down to do in class. So we'll go ahead and do it. Horizontal asymptote. I have x squared over x squared, which reduces to 1. So y equals 1 is my horizontal asymptote. Point of discontinuity we have to look for. So -2, -1 would be -2 and 1. And the bottom, -6 and -5. Would be -6 and 1. 1 times 6, 6. 6 minus 1, 5. So x minus 6, x plus 1. And there it is, our point of discontinuity. X plus 1 equals 0, so it's at x equals negative 1. Now if I put negative 1 in, I would get negative 1 minus 1, 2 over negative 1 minus 6 would give me negative 3 over negative 7, or positive 3/7. So right about there. Okay, vertical asymptote. Take what's left of the denominator. X minus 6 equals 0, so x equals 6. So horizontal asymptote, 1, 2, 3, 4, 5, 6. Vertical asymptote, and now let's just play with numbers. And remember, we're only using x minus 2 over x minus 6. So if I put in 5, I would have 5 minus 2 over 5 minus 6, which gives me 3 over negative 1, so negative 3. And remember, 1, 2, 3, 4, 1, 1, 1, 2, 3, 4. There's that point. If you wanted to do this one, you can, but it's not going to work very well. So I'll just go to 2. I'm sorry, that's not 2 anymore, is it? Oh, this is 6, so this is 7. 7 minus 2 over 7 minus 6 gives me 5 over 1. So 7, 1, 2, 3, 4, 5. Something's not right. Okay. 1, 2, 3, 4. 1, 2, 1, 1. 1, 2, 3, 4. Let's verify it. Oh, this is a 7, this is 8. Six, 7, 8. Okay, so 8 minus 2 over 8 minus 6 gives me 6 over 2, which is 3. One, 2, 3. And 1, 2, 1, 2, 1, 2, 1, 2. And we can draw our points. And be careful of your hole that you don't actually graph over it. You gotta skip it. And there you guys go. Now we can talk about any one of these problems in class, step by step, how to do them. But there you guys go. And what's left, this was assigned for day 1. So this is from part 1, day 1, whatever you want to call it. And it was every other odd. And for part 2, for day 2, and this is every other odd. Okay, and there you guys go, and good luck.